Imagine you're shopping online. You click place order. Within seconds, your payment is processed. Inventory is updated. A request is created. You receive an order confirmation message. But does the order system directly call every other system one by one? May not be, right? In modern applications, the answer is often no. Instead, systems communicate through events. This architectural style is called event-driven architecture, and it powers many large-scale platforms like e-commerce, banking, logistics, any real-time application. So, in this session, we will understand what is event-driven architecture. So, basically, this is also an architectural style where systems communicate by producing and consuming events, right? An event is simply a notification that something important has happened. One system communicates through other system through events, right? Again, what is event? Event is just a simple notification, like this particular event has happened. Like examples, um, customer registered is an event. Order placed is an event, right? Payment completed, money transferred, or shipment created. All these are events, like something has happened and completed, right? This is event. The service that creates the event is called producer, producer of the event. The service that listens and react to that event are called consumers, right? Producer, event created, consumer, event, consumer, right? The communication usually happens through an event broker or messaging platform, right? We have seen in one of the earlier session where we wanted to send information from a, a component A to component B, where we used queue or pops up topic, right? These are all messaging systems. So some of the examples of the real world messaging systems are Apache Kafka, uh, RabbitMQ, right? Other cloud messaging services. Now, let us understand this with an example. Right? Now, a customer places an order in any e-commerce applications, right? Can be Amazon or Flipkart, anywhere. A customer places an order. Okay. So the very first step is the order service comes in picture. The order service receives the request and creates the order, right? Instead of directly calling payment, inventory, notification services, it pushes an event, right? Order is created. That is an event. Now it has to call to other services. Instead of calling the API of payment inventory notifications, what order service does is it creates an event and publishes to the other consumer services. right? This event um, might contain information such as order ID, customer details, product details, order amount. All these are required by other services, payment, inventory, and notification services. Now, um, what is the next step, right? The event is stored and distributed by an event broker. Event creation has happened, and that event has the required information. Now, the event broker stores and distributes that event. The broker acts like a communication channel between different services. The service order does not need to know who is interested in this event, because once it creates the order, places the order, creates the event, and pushes that event, the job is done. Now, the order service essentially need not to know who is consuming that service and how they are consuming. It simply publishes the event, right? Mm, we have payment service, inventory service, and notification service, right? Who are waiting for that event. Okay? The payment service receives the event and processes the payment, right? We have orders, we have payments, inventory, and notifications, right? Event is created, right? Now, this event, this is messaging service. This event is pushed, right? Now, the event is sent to payment, right? Payment receives the event now at this stage, right? Now, payment receives the event and processes the payment, right? After successful payment, it just says that the payment is completed, right? That is also an event, right? Payment completed. Now, coming back to our orders. Now, the same event is sent to inventory service. It receives the order event and updates product stock, right? What is sold and how much is remaining. Basically, the inventory management, right? The same event is used by notification service. It receives payment completion and sends your order has been confirmed, right? Now, the same event is sent to payments, inventory, and notifications. These payments in inventory and notifications are using this event independently. They don't know each other, or the order service don't know how these services are consuming, right? Now, what are some key characteristics that event-driven architecture provides? The very first thing is loose coupling, right? Services don't directly depend on each other. The order service does not need to know how payment and notification works. If there is any change in payments, the order and the other services are unaffected, right? And the service can process events independently instead of waiting for immediate responses. Once the event is received, right, the payment service handles the event in its own time and space. It is not dependent on other services. Right? Now, order is not waiting for any confirmation from the payment. It created the event and pushed the event. Right? It is kind of asynchronous instead of directly making API calls. Right? And again, scalability is the one advantage that event driven provides. We can add as many services as we want, independent of other existing services. Either it can be producer side or it can be consumer side, right? This is the producer and this is the consumer. And it provides real-time processing of data, which helps in fraud detection, stock updates, right? We have seen in the inventory. As soon as the order is created, the inventory is updated so that the stock is updated. Again, the notifications, right? The user is immediately informed that the order has been placed. So it provides better scalability and flexibility of consuming events, right? And each service are independent. So failure of one service will not shut down the entire system. Other services can still run, or changes to one service does not require changes in all the other services. But um, it becomes little difficult to debug what is wrong because again independence has both advantage and disadvantage, right? The order service does not know how the information is consumed by payment, inventory, and notifications. It just created the order event and pushed it to the requiring services. Now, order service don't have control over the information. This might cause difficulty debugging. So, in nutshell, event-driven architecture allows applications to communicate through events instead of direct service to service calls. Right? A producer creates an event broker distributes that event, and multiple consumers react and consume that event independently. This architecture style is extremely powerful for large-scale real-time systems. Thank you for your valuable time. This session is part of Software Architecture series. There are more topics covered in different sessions. Please take a look and we will see you in next session. Thank you.